In this video, we're going to have a look at the storage devices and media section of the IGCSE Computer Science syllabus. What it means by storage devices and media is the difference between storage device and media is a device is something that you can do things with, basically. So it has some sort of moving parts, so you can control it in some way. And media is something like a CD or a DVD or a Blu-ray. These are the individual storage devices and media that you need to know about. For each one of these, you need to know the basic principles of operation, so how they work, only on a basic level, what they're used for, advantages and disadvantages in comparison to each other. So let's get started. The first one we're going to have a look at is a CD. So, in terms of the basic principles of operation, all you need to know is that a CD has inside it spiral tracks. Okay, so on a CD is a track that goes like this, and then it goes inside itself like that, and they go round and round like this. Inside each one of these spiral tracks are grooves and bumps. Okay, each one of these little grooves gets light shone on it by the laser of the CD reader, and depending on its frequency and how wide it is, it represents binary zeros and ones. Okay, so a light shines on it and it reads the grooves or the bumps between the tracks, and the length and the frequency of the grooves represents the digital data. So there's a groove there might be another one over here, there might be one down here, and this will represent all the zeros and ones, and it will get put together by the computer to represent whatever data is on there. Okay, that's the level that you need to understand. The CD has a wide wavelength of light. What that means is that the grooves have to be bigger, okay, compared to DVDs and Blu-rays, and therefore, because the grooves are bigger and the bumps are bigger, the CD can hold less data. So down here you can see we've got a lower storage capacity compared to other media. The advantage of a CD, however, are that they're extremely cheap to manufacture. You can pick these up for literally pennies or cents in any store. They're easily transported, you can stack them on top of each other, and they're the devices that run them are cheap and very popular. Okay, so you can go anywhere and get a device that reads a CD. You don't have to go to some sort of specialist place, and they're extremely cheap generally to buy a CD drive, for example, for a computer. The disadvantages are that they've got low storage capacity compared to other media. They're extremely fragile. Okay, if you were to, these bumps and these grooves on here aren't actually this big. I've just done that to represent them, but if you were to scratch it, it might scratch the equivalent of across this part here, and we've lost all of this groove. So if you scratch one of these even lightly, then you miss part of the data. And if it's a CD, because the data is continuous and it reads it over all of this like a record, it might just skip part of the CD. It might continually just go round and round and just read the same part of the CD. But if it's a piece of data, then you might be missing something like an image or a video. You might be missing some sort of integral part of the header information, and therefore it might not run at all. They've also got a slow read-write speed. When we say read-write speed, what we mean is how fast they can take data onto them so we can write to them, and how fast we can take data off them. They are slower compared to the other devices that we're going to look at. Okay? There are other types of CD. There is CDR, CDRW, but they're rewritable CDs. If you ever see R, okay, versus RW, then this means that you can just read it, and this one means you can read it and write it. So you've got CDR and CDRW. We've also got CD plus R. Okay, and this is just a little difference between manufacturers that came out with slightly different types. I think Philips came out with a plus, but you don't need to know that for the exam as far as I know. However, R and RW are read and read-write. Next, we've got the DVD. The difference between a DVD and a CD, they're exactly the same principle of operation, but we can fit more on a DVD. Okay, on this one example, we've got 8.5 gigabytes. Generally, on a CD, probably should have told you that. On a CD, we've got around about 700 megabytes maximum capacity. Okay, for a DVD, we've got much bigger. We've got, this one's got 8.5 gigabytes. Generally, for each layer, you have around about 4.7 gigabytes. However, they can be dual layer, or they can be multi-layer at least, which means that you can have different layers on them that different can be accessed one after the other. Okay, so we can read the entire layer, 4.7 gigabytes, and then we can switch to the next layer. If you do that on a DVD player, you might notice that it skips a little bit. If you're ever watching a DVD and halfway through the DVD it pauses slightly and then it carries on, it's because it's switching the layer. The main difference in principle of operation between a DVD and a CD is that the DVD has a narrower wavelength light. Okay, so the light that shines from the laser is narrower, and therefore it can read narrower bumps. Okay, so the bumps in the CD need to be narrower, and therefore, because they are narrower, we can fit more of them, the bumps and the tracks, on there. Okay, so we can fit more data on there. So that is a higher advantage. As before, they're cheap to manufacture, a universal format, and they can be dual layer, as we've seen here. Disadvantages, again, they're still fragile, and compared to some of the ones that we're going to come on to now, they are a lower storage capacity. Okay, next we've got Blu-ray. Again, the difference between CDs and DVDs is that this one has an even narrower wavelength. Whereas with CDs and DVDs we use a red laser, with a Blu-ray we use a blue laser, hence the word blue. The blue laser light has a very narrow wavelength, which means that we can read very tiny bumps. And because the bumps can be tinier, we can fit a lot more data on a Blu-ray disc. We can fit around about 50 gigabytes on a Blu-ray disc. We can also have those as dual layer as well. As with CDs and DVDs, they are fragile, and they're also they've been quickly overtaken by streaming media. It doesn't seem that Blu-rays were popular for all that long, and they didn't really massively take off as much as expected with movies, mostly because things like Netflix came out quite quickly afterwards, which offered streaming services, and bandwidth and sort of the amount of data that's allowed by ISPs has almost destroyed the Blu-ray disc, but it's still around at the moment. Next, we've got hard disk drives. The hard disk drive is likely to be the main drive in your computer. Most computers have a hard disk drive, and it's used to store the operating system and anything that you save. They don't all have hard drives now. For example, the computer I'm using just has SSDs. I don't have a hard drive in it, for a reason we'll come on to later. How a hard drive works is they've got these spinning things here called platters. A platter is a metal disc. On this metal disc there are millions and billions of tiny little magnets. Each of these magnets are either, oops, I need a pen, are either north polarized or south polarized, okay, right, and they represent zeros and ones. So if you imagine a little magnet, if we make it point north, then it represents 1. If we make it point south, it represents a 0. And if we change these depending on the zeros and ones that we want on the disk. There are billions of these, and this little arm here, okay, it spins. You might have seen it before, pointing up that way. Okay, it's got a little electromagnet in it, and it reads where the zeros and ones are, and also it can change those zeros and ones. They've got a fast read-write speed compared to things like CDs, DVDs. They are long-lasting, and they're generally quite durable. If you ever open one up, they are immediately destroyed, but generally, unless you open it up, they're relatively durable. They have a large storage capacity. You can get these now in terabytes quite cheaply, okay? And as it says here, they've got a cheap per megabyte storage. So what we mean is the amount of money, the amount of dollars or euros or pounds that you're paying per megabyte is quite low with one of these. The disadvantages are that they've got moving parts. So if you've ever got a device that you need to move around, one of the questions in the previous IGCSE exam was, it gave you a scenario that was a drone which was taking some sort of footage. What hard drive, would it be okay to have a hard drive in it? And the answer was no, because they've got these moving parts, which means that they are durable, but if you start shaking them around, then this arm starts shaking around the platter. Also, you need to avoid with the magnetic field. So if you're working in some sort of environment that has a high magnetic field, these aren't suitable. They're not as large as... actually, that's not true. Let me rub that one out. They're not as fast as an SSD, that's supposed to say. Not large. They are larger than an SSD. Fast as SSD. They're not as fast as SSD in terms of read-write speed. Okay, so if you are reading and writing from this, they are very fast in terms of comparing them to a CD or a DVD, but when you compare them to an SSD, they aren't as fast. I've got that repeated there, but that really drives home the point. Okay, next, we've got SSDs. SSDs are solid-state drives. They work with these little electronic chips. They don't have any moving parts in them. The principle of operation, it very quickly goes very, very complicated, but basically how they work is they have electrons in them, and if we fire a signal through them, these electrons can be floating or they can block a signal. So they can, kind of like a logic gate, they can either allow a signal through or block a signal, which makes a 0 or a 1 with these floating gates. All you need to know basically is that they have no moving parts. They use electronic chips. Okay, they sometimes use what's called, they used to use RAM memory, so random access memory. Now they sometimes use NAND flash. Okay, NAND flash is a series of theoretical NAND logic gates. They're very, very fast to read and write. I've got an SSD. As I said, I've just got SSDs in my computer. The boot up time for Windows 10 is around about 8 seconds. The equivalent hard drive boot up time is around about 20 seconds. Obviously, it depends on the speed of your hard drive, but they're very fast to read and write from. They're compact in size. They're very small because you don't have to have these platters, these discs built on top of each other, and you don't have to have a moving arm. There are no moving parts, so you can put them in something that moves around and there's no problem with that. The disadvantage is that at the moment, this is very important, at the moment they have a lower storage capacity than hard disk drives. If you watch this video in 10 years time, all this will probably be irrelevant, because I'm sure that these will overtake anywhere that we got with hard disk drives. But at the moment, they're a lower storage capacity and they are much more expensive per megabyte. Finally, we've got flash storage. Flash storage can cover USB sticks, any sort of card that you put into your computer. They are small and compact, and they've also got a relatively fast read-write speed since USB 3. USB 2 was quite slow. USB 1 was quite slow. They were also only half duplex, which meant you could read or write. You couldn't do both simultaneously. With USB 3.0, you can read-write at the same time, full duplex, and they are quite fast. The disadvantages is that they have a lower storage capacity when compared to physically larger drives. They work in the same sort of principle as SSDs, okay, using these floating gates to store data permanently, even when the power's switched off. Because as you know, with RAM, when you turn the power off, everything disappears. With these, it doesn't. Okay, so there, hopefully, it's a bit of a whistle-stop tour, and it's very quick, but you don't need to know much about this topic. They are unlikely in the exam to say list advantages and list disadvantages. They might do, but what they seem to be moving towards is giving you scenarios. So, for example, they'll give you a scenario of some guy wants to take his work home. He only uses pictures, a maximum of 20 megabytes. He doesn't have a big bag, and it's trying to point you towards a USB stick or a SD card. Have a look at the previous exams, see what questions they ask you, and work from